Hello and welcome to Winslow Academy. In this StarCraft AI series, we are going to learn how we can, using the Python programming language, create a StarCraft AI bot that will basically win a game for us. We'll be using the Python programming language, as you see right here. So first of all, you will need to have StarCraft 2 installed. You can download this free from Blizzard by simply going to starcraft2.com, create a Battle.net account if you don't have one, and then basically just download the StarCraft 2 client, and then you should be ready to go. You will be needing it because we will be basing our Python code on the StarCraft 2, and since we are creating our bot for this game, we also need to have the game installed. So go ahead and download it if you don't have it, and once you have done so, you can go over to your IDE. I chose to use PyCharm for my Python code. You can download this if you want. There's a 30-day free trial by simply going to JetBrains PyCharm. So jetbrains.com and then /PyCharm, and then you can download a 30-day free trial, and then you can follow along with exactly the same IDE that I'm using. So once you have done so, we will be needing to download the StarCraft 2 API package. So you will go to Files, Settings, after you have created a new project, and then we will be going under Project C2, then you say Project Interpreter, and then you click plus. And of course, if you haven't not installed Python yet, you'll probably not see this right here. So you will simply just be going to Google, type Python, and then you will be downloading the Python version. Remember that you will have to choose Python 3 point something to follow along what I'm coding, because there are two different Python versions. There are the 2 point something and 3 point something, and we'll be using the 3 point something. And there is a difference in the syntax in them and the methods that is used. So to follow along here, I recommend you take 3 point something. Now I'm using 3.7, but depending on when you're seeing this video, you might have a higher version. So you will click plus here, and then we'll be needing to have the package installed. The one we'll be using is called PyCS2, so this right here, and the author of this is DeepMind, and you can read more about this by simply just going to their GitHub page, where you can read more about how this works and what you can do with it. But basically we'll be doing similar in this video to what the basic steps is right here, and then in the upcoming videos we'll be moving quite further than what they're doing here, because they are not showing you how to create units and do attacks and build different buildings and so on. But here you can read some more about this package and framework. So we'll be closing this, and then we'll click install package. Once the package has been installed, you can simply just click close right here, click OK, and then we'll be creating our first Python file. So we click new on the project folder here, then we'll click Python file, and we'll just call this py/agent. Yeah, it will be a Python file automatically if you're using this IDE. So we'll create this here, and this is just a name that I chose. You can choose whatever you want as long as you are creating a Python file. So the first thing that we're going to do is to import what we need. So we'll say from py/c2.agents import base agent. Then we will say from py/cs2.in for environment, we will be importing cs2 environment. Then we will be from ps2.lib importing actions, features, and units. Then we will be needing the ABSL from the app, and then we will be importing random, because we will need to generate some random numbers for our x and y coordinates when we are getting into building actual structures. So the first thing that we'll be doing is to create our method for executing our application. So we'll say if name equals main, we will say app.run, and then we will be running the main. like so. And now it is red because we don't have any reference to main. So we'll head on and create our method. So we'll say def main, not like this, and then we will say unused argv. Then we will, we need to say like this, and then we will say agent should be equals to our py agent, which is a method that we are going to create. But first we'll be done with setting up the entire environment that we will be needing. So we'll say try, like a try catch, which you should be familiar with if you have coded before. If not, I have a tutorial on basic Python programming on this channel as well that you can just follow before you start doing the rest of this code. But let's get on. So you'll say while true, so while true, and then we will say with cs2 env dot cs2 environment, and then we will say, now we will be defining what map we will be choosing, what players should be within the game, and whether we want to see the graphical client of the game. So we will say map name equals, and we'll be using symbol 64. I'll be showing you how to download this in a second, because you don't have it as a standard. So to download the symbol 64 map, you'll be navigating to this github/blizzard/cs2 client protos #map package. I will be linking to this in the description as well, and then you can see the different packages that you can be downloading. To get the symbol 64 map that I'm using in this tutorial, you'll be needing the melee map package, so you click download on this one. Then if you try to open this, it will say that you need to enter a password if you want to extract it. The password you'll be needing to open it is I agree to the URL right here. So you can just enter this, and then you will have access to the package. So once you have unzipped the file with all the maps, you'll be going to a StarCraft folder. You'll be creating a capital M maps folder. Within this you'll be creating the capital melee folder, and in here you will have the maps. And here you see the symbol 64, which is the map we are using. You can also try this map if you want to experiment a little with them, but you need to have this map placed within the StarCraft folder in this structure right here for your code to work, because you don't have it as a standard. So we will say players equals cs2 in dot agent, and then we will say cs2 in dot race dot Terran, because we will be playing as Terran, and then we will say cs2 dot inf dot bot, which is the player that we are going to play against, so the StarCraft 2 bot, and we will say cs2 inf dot race, and it should just be random because we really don't care who we are facing. But we need to know exactly what race we are, because we need to define the buildings and so on that we can build, and if we don't know who we are, we will need to create a lot more advanced checks, because each race in StarCraft have separate builds and separate structures and so on. So we will say cs2 inf, and then we can choose the difficulty of the bot that we are playing against, and ours will just be very easy because our bot is very basic, so we don't want to be crossed instantly by an hard AI. So we'll say agent interface format, and we want to say features dot agent interface format, and we want the feature dimensions. So this is the dimensions of the game client that you saw in the introduction, where we will see the actual game as it unfolds. So we'll say features dot dimensions. So we just want a little, we don't want a full screen, because I also want to see as you saw, the image map where we have a better tracking of what is going on, and then we can see what our AI client is actually seeing and what it can react on, because we are able to see what kind of actions it is capable of taking at a given time. So we'd say 84, and we want the minimap to be 64, like so. And then we simply just say use feature units, and we want that to be true. Then we will say step bull, and this is basically where we define the actions per minute. So we'll just choose 8, which is a normal, which is the normal APM according to around 300 actions per minute. So this is fine for our bot here, and then we will say game steps per episode, and we'll say 0, and visualize equals 2, and we'll say as inf. So here we will say agent dot setup. So agent is the agent variable we created here, and that will be based on a method that we have yet to create. So we'll say dot setup, and then we will say inf dot observation spec, and that is because we need to be able to observe what kind of actions we are capable of taking and what is going around in the environment. So we'll say actions spec, and then we can close this off, and then we will say time steps, and that is our variable, so that will be our environment slash reset, because we'll be resetting this. So we say agent reset as well, and then we will make another while true, so we'll say while true, and then we will say step actions equals agent dot step, and then we say time steps, which is the one we created here, and then we will take the first element in this array list, and we will be closing this off, and then we will say if time steps dot 0 dot last, then we will say break. So simply just hold the execution because there are no more to do, and then we will say time steps equals environment dot step, and then we will say step actions, which is the one we created right here. So now we will be going down, and then we head back here, and then we will say accept, and we will say keyboard interrupt, and we will say pass right here, be here, and we need to close this off here. So, and here we have to have a capital T. So now the only error that we are having is that we are currently not using the method right here, because we don't have any reference for this. So we'll be creating this little class here. So we'll say class, then we will say Py agent, then we will say base agent dot base agent, then we will create a method within this that is called step, and it will have self and obs, which is the observations that we took from when we created this here. So we will say super, and then we will say Py agent self dot stop step, and then we will say obs here, and then we will basically say return actions functions, and it is called no up, like so. So now we should be able to run this. We'll try this in a second. And the actions here, if you enter the actions class, you can see all the actions that is defined. So we will have a list right here where you see, for example, here you can build a gateway, you can build a nuke, you can build a nexus. All these different things that you can do in StarCraft can basically be controlled from here, and you can see what the name is and so on. And there is really a lot you can do. So if you want to see what is possible, you can, in actions and so on, you can just enter the class and take a look around. So let's try to execute this. So we'll go up to run. Then we will say PyAgent. And remember, you have not yet downloaded this, so you'll probably get an error if you try to execute this. But we'll be downloading this in just a second. So we see StarCraft is starting up here with our simple map here. So let's see, we have an error in line 37 here. So let's take a look and see what might be the error. So we have environment close, we have agent step, time steps. Oh, let's see, time step. So let's see if we have, so we'll be taking this just to ensure time steps here, time step here. So we'll just try this once more. Oh, so we have again an error. We forgot this one. So hopefully we are done with all the errors, but at least you got to see how careful you have to be when typing this. And if you're seeing more errors than this, then I recommend you to go a step back and then rewatch the video to ensure that you have written exactly what I have done, because even though you don't see any errors indicating in the IDE, there might still be something that you mistyped or you just forgot adding while I was going through it. So it is always good, if you can't get this to work, to just rewatch the video one more time and then be sure that you have written exactly what I have done. When I'm done with this tutorial, I will of course be uploading my code on GitHub so that you can see exactly my code. But as you see here, we now got our CSVs to farm some crystals, and basically that is all our AI bot is doing right now. So at some point our enemy will be attacking us and we'll in the end basically just die. But yeah, in the next lecture we'll be looking at how to create supply depots and a barrack, and then we'll start to make marines and be ready to defend when we are getting attacked. So
everyone should have the opportunity of influencing the world of tomorrow by learning high-impact tech skills. Take back control of your time and stay efficient by planning your daily tasks and learning activities using the Academy Planner. Browse through your favorite personal resources and keep track of your learning progress. Our belief is that people learn differently, and we do therefore support resources from around the web to ensure the best possible experience. The Social Hub enables you to connect with like-minded users. You can either dive into already established topics or be a first mover and create new topics that can inspire other learners.
So let's get into it. So this is what our bot is capable of now, starting the game and simply just mining. So it isn't really doing anything yet, but that is what we're going to change. So we'll close this down. Then we'll go up here in our step method we defined in part 1. Then we're going to make it select all the CSVs, because we need to select a CSV in order for us to utilize the actions that it can do. So when selecting a CSV, we are capable of building some basic structures. So we'll say drones. I'm writing drones because then it is more suitable for all the 3 factions. We have the Protoss, Terran and Zerg, and if you want to change it, then drones is basically just common for all of them, even though they are called different things. So we'll say drones, and this is just a name. You can name it CSV if you want to, but we'll just stick with drones. So we say drones unit for unit in ops and observation, and remember that this was the input to this method that we got from our game here when we started the client up. So we'll say observation, then we will say feature units, and then we will say if unit dot unit type equals units dot Terran dot CSV. So here we can see different unit types that a Terran can have, but we will be needing to select the CSV, so we'll select this. Then we will say if length of the list that we create of available CSV is higher than 0, so this length should be higher than 0. Then we say drone equal random. Remember we imported random in the part 1, so now we are using this random choice. Then we say drones, so we are picking a random drone here, and then we say return actions dot functions dot select point, and then we select all type, and then we will be saying drone dot x drone dot y. So let's try to run our application again and see if we are selecting all the CSVs that is available. So let's see, and now you see we have selected all the CSVs, and this gives our bot some different type of commands that we can use. So we can attack with our CSVs, we can build a command center, engineering bay, supply depot, and so on. So we'll be building a supply depot at first, because after we have built this, we are capable of building a barracks, and that is what we need to create marines. So now we have selected all the CSVs, so we can be closing this down. And then we will be creating our supply depot at first. We will do this in a separate method, so we'll say def build supply depth, and then we say self, and obs again because we need the observations, and then we say supply depth equals self dot get units by type, and we need the observation here, and we say units dot terran dot supply depth, and then we say if length of our supply depths. Again, we are looking at the length similar to what we did with the CSV in the drone here, and if that is equals to 0, meaning we don't have any, we are going to build one. So we'll say if self that unit type is selected. We'll give this as an input. So this is a method that we're going to create, but now I will just define it and then we'll create it afterwards. So we say units terran dot CSV. Then we say if actions dot functions dot build supply depth screen dot id. And remember, this here is similar to what we have find in here. So here we can find the build supply depth screen. So this is the one we are using. And then we will say obs dot observation dot available actions. So then we are going to say return true, and we will need to have this in here, and here we will say return false. So let's see. Oh, we need to remove this here, and like so. So here we are basically making a check, and if we see that we are capable of executing this action, we will be returning true from this method, or else we'll be returning false. And the reason we are doing this is because we want to check if first, do we have a supply depth, and have we selected our CSV, and do we then have the capability of building this supply depth. So here we will simply just be going to the method here we just created, and then we will say no, we'll here because we just need a bit more. So we will say def, and we'll be creating, just invoking these here, so they are within this class. So we'll say def get units by type, because these are the methods we are using here. We need to create two. So we will say self and obs, and then we need to take this input as well. So we will say unit type, and then we will be returning unit for unit in obs dot observation dot feature units, and then we will say if units dot unit type equals unit type. So basically here we are getting the unit by type, and we are taking this as input. So we just created this method that we utilized here. So we just need one more method, and that is this one, unit type is selected. So we'll be saying def unit type is selected. It will take obs and unit type as well. And here we will say if length of observation dot single select is higher than 0, and our ops dot observation dot single select this list here dot unit type is equal to the unit type we gave as input. Then we're going to return true, meaning that we will be fulfilling the statement we are, let's see here, meaning that we are fulfilling this statement right here where we have a if statement. So we are returning true, and else we will be returning false, and then this would return never get to a true state where we will be building the supply depot. So now we have these three methods. What we need now is to call this method where we will be building our supply depot. So basically all we have to do now is to call our, let's see, build supply depot method right here, and then we will be saying self, and then we'll be giving an operation, and then we say x equals random, so we're using this random library here again, and we will say random, oh we forgot to use a dot, like so, and it should be between 0 and 83, and we need to do the same for the y. So here we are getting two random coordinates, which is going to define where we are going to build the supply depot. So it will be a different place each time because these numbers are to be random generated. Then we can simply just say return actions dot functions dot build supply depot screen, which is the action, remember, we saw here. And then we can say we want to build it now. If this is true, which is the method here that we just made and got evaluated, so we will say now, and it should be built on our x and y random generated coordinates, like so. So let's try to execute this and see. And let's see. Build supply take 2 positional arguments, but 3 were given. So we have it on line 13 here. It takes 2 positional. So what did we give? And we have build supply here. So we'll just be removing this. And then we should be alright. So now it is running, and hopefully we should soon see that our supply depot will be created. It somehow sees that it is not, so let's see what might be the error. Let's execute this. Oh, and we forgot to, we only made the single select here, so we'll be copying this line here. And then we'll simply just make this count for multi-select as well. So we'll say multi. Here should be higher than 0 and unit type, and if none of these are true, then we will simply just return false, like so. And let's see then, because we have not made a single select, we have actually made a multi-select because all our units have been selected. And as you see now, it just made a supply depot, and we can go here and see we are now building the supply depots. So now we just need to make it create a barrack, since we now have this build barracks command available. So to do so, we will simply just be needing to copy this method right here. So we can copy this, then we can say build barracks, and instead of supply depot we will be building a barracks. So we'll say barracks here, and use this to check the length of. We have screen right here, and here it should be build barracks, and then we should be good. So we can go up here and we can copy this one as well. So we'll make a check for our build barrack. We'll use random coordinates again, and here we just need to tell it to build a barrack. So this should be all, and if we now execute this, then it should first start mining, build the supply depots, because that is the only available action it has based on what we have told it to do now. Once the supply depots has been built, it will see that it can now build a barrack, so it will start building one. And let's see. So here we got the supply depot created right here. Once that is built, it seems that we have a little error. So let's see. Key error, build barracks screen, and we have it in line. Where is our line? We have it line 21. Function build barracks screen, and let's just enter the actions. Let's copy this here, and let's see. It's with an S, so we can just copy this and paste this. So we forgot to add it with an S, and we'll go down here as well. Oh, and we have a S here, so that should be fine. So let's see. We see a supply depot being built here, and once that is complete, it should hopefully start build our barracks. As it will see, the command becomes available, and here we have the barrack. So now we are building a barracks, and the next step will be to build marines and defend or attack our opponent. So we'll build on top of what has been learned in part 2. So we'll start off by creating a new method here, where we will be saying build marines. So this will be the method that we'll be using to build the marines, or tell our script to build marines whenever we have less than 4 marines in the game. And when we first build our barracks, we of course have 0 marines. So we will say marine, which is our variable within this method, and then we will say self dot get units by type, which is the method that we created in previous lectures right here. And then we will say ops, which is the world that we are observing, and then we will say units dot Terran, because we are playing as a Terran, and we want the unit to be a marine. So now we will have the entire observed marines stored in this variable, so the count of them. So now we can make a check and say if the length of the marine is less than or equals to 4, we should do something. So this means whenever we have more than 4 marines, this code that we are writing here will not be executed. So you can make this 10 or a dynamic value by making it calculate randomly, but we'll just stick with 4 here. And then we will say if self dot unit type is selected, which is also one of the methods that we have been creating from previous videos. And then we will say ops, and we will say units dot Terran, and then we will say barracks, because now we need to know, need to have the barracks selected in order for us to create marines. So if this checks go true, we will make another check and say actions dot functions, and then we will say train marine quick. And remember from last lecture that if you click into this class here, you can see all the functions that you have available right here. So we are just using the one where we train a marine, and there is a lot of other stuff to train, basically everything that you can create within StarCraft 2. So we'll be using the train marine quick, and then we will say in, and then we will say ops dot observation dot available actions. So what this is doing is checking whether the function train marine quick, the ID of that, is available within the available actions that we can do based on what we're observing right now. So I will show you this when we execute the application, that the actions that we are capable of doing shift based on what we are selecting in the game. And in here we will say return true, and if not, we will say return false. And we'll just do like this, and it should be capital F, like so. And now we just need to call this method right here. So we'll go up where we have executed the build supply depot and the build barracks, and then we will say if build, let's see, oh here, so we will say if build marines, and we will say self observe, like so. And let's see on solid reference, so does it have the right, oh, and as you see here, the reason why we can see this is because we didn't build it in the right space. So we'll just select this and take it one step out, like so. And now this error is resolved. And that is what you have to pay attention with when coding Pythons. You need to have the right intention, and basically if we do like this, the code suddenly start to mean something else, and we'll also get an error. So it is important to be aware of this. So we'll go back here, and then we will say return actions dot functions, and then we will say train. So here we are going to use this marine quick action So train marine quick, and we are going to do this now, meaning that whenever we have passed this check here, which is the method here that will return true if we have less than 4 marines, if the barracks is selected, and if this action is available, then we will be executing this function, and we are going to do it now. Now we just need to make something that will select the barrack for us, because currently we only have this drone select. So we are going to make a similar feature like this. So we are going to copy this here, and then we will say barracks instead, and just like so for our local variable. And then we will just say, instead of SCV, we'll be using barracks. And then we will say if the length of barracks is higher than 0, meaning that we have at least one barrack available, then we will say return actions functions and select point. And then we are going to do a select all type, so similar to the exact line here, but instead of having drones, we'll just be having barracks.x and barracks.y, and we're going to have these within parentheses like so, and just an ending one here. So now we should have the code needed, so let's see. We will just be executing this and see if we will be creating some marines. So what our application should be doing now is it will check if it have less than 4 marines, and that means 4 created marines. So it will probably spam our barracks with creating marines until we have 4 created. So we'll actually be getting 9 marines in total, because it will create 5 marines in queue, and then it will pop one out, create one new in queue, and so on until it have 4 marines on the board, and then it still have marines in the queue. So we are building our supply depot, and if we go to this window, we'll see the actions right here. So this is what is going to shift and what we are checking for. Oh, we had an error, and that is because we forgot the line where we choose a random barrack. So we'll just say barrack, and we'll say equals random choice, and it should pick from the barracks if we have created more. And then this should not be the barracks, but simply just a single barrack. And now we'll try and run this. So we are creating a supply depot right here, and following that we should be creating our barracks, and that will be created right here. And let's see, we had an error, and that is probably because we, let's see, build marines. Yeah, we capitalized this, and that is not supposed to be capitalized. And we also forgot to capitalize this, and let's see if we also forgot it up top here. So function select, and yeah, so we'll just be saying functions like so, and then we will try execute again. So in this window we see the actions that is available, and that is the ones we have used, like train, marine, quick, and these will change based on what is selected. So now we'll be creating our barrack, and once that's complete we should start pumping out marines. So let's see, and here we are now creating 5 marines, and we will be training one. There comes one, and we will queue another one, and basically that is how we are training simple units with this AI script. In this part 4 we want to attack our enemy with the marines that we created. So we'll build on top of what we have built so far, and if you haven't seen the 3 previous parts, then I recommend you to do so to get the code that we are working with right now. So first of all, we'll be reusing some of the code that we did before. Here I will be copy pasting some of the code that we have done, which is not that intuitive, and if you want to optimize this, you should of course build singular methods that can be used multiple times instead of having them copy paste. But this part 4 is the last lecture where we'll be doing so, and it is also the last lecture where we'll be doing this kind of static programming of the bot, because here it will always do the same steps and there is really not that much machine learning. But this is all to give you an introduction to how this framework works before we start to build on an AI that will utilize these functions. And then we will get rid of some of the code that we have written, and some of the other code will simply be rewritten in order to adapt it to how the AI is going to work. So we'll be creating an attack method, and in here we will say marine. We'll keep this because we still want our units to be the marines, and here instead of having less or equals to 4, we will say if the length is higher than 5 marines. We don't want to select the barracks here, we want the marines to be selected, and in here we will simply say if action and functions, and there is an attack screen .id, and that means that we have selected the marines. We will be doing the select part in a few minutes, and when we are selecting the marines, we'll be able to attack with them, because that is a function that you have in StarCraft when selecting units. So if the attack screen ID is present, then we'll be returning true because it's available, or else we'll be returning false. So now that we have this little attack function, we'll go back up here in our step function, and we'll just be creating this right after we'll just say, we'll do it here. So right after we have the build marine check. So here we'll say marines, and then we will say units like we have right here, so we can copy this. So as you see here, we are reusing the same code a lot, and that is because we want to get used to how this works. So it's really, if you want to build on top of this and do it with another faction than Terran, it's really easy for you to adapt. So we'll just be changing this again to marine, because it is the marines that we want, and then we will say if the length of the marines, because here we are going to have a list of all marines, and that is higher than 5, similar to what we defined in our attack method here. If that is higher than 5, then we will say a single marine should be equal to just a random choice of our entire marines. And then we will simply just say return actions, and then we will say functions dot select point, and we will do a select all type, and we want it to be the marine.x and marine.y because of the coordinates, similar to what we have done with the barrack and the SCV. So now that we have this, we will simply just be saying if attack, which were the method we created right here. So now we are calling this function. If that, and we need the self and the observation, because this function is constantly relooping and observing what it sees on the screen. And then we will say if that is true, we'll simply just be return an action, and that is to be a attack minimap action. And as I have told in previous parts, you can go into these methods, and for example on the functions you can click deeper into functions, then you will get into actions, and here you will see all the different actions that you have available, and we have our attack functions here. So we'll be using the attack minimap, and we will just say 0 because we don't want it to be the queued units, and the coordinates we are going to be attacking is 1923 because we are probably going to start in the bottom right corner. So this is again static, and in the next lecture, part 5, we'll be rewriting this and be doing it in a intuitive way such that the machine learning but will simply learn by itself where it's placed on the map, and then it will go search for the enemy instead of us telling it that go directly to this location, because what if the enemy is not there? Then we are just standing there doing nothing. So with this last line we will hit execute. And we'll just move this to the side so that we can see the actual game and the actions we have available. So first off, we are creating a supply depot. Following that, we are creating a barracks right down here, and you'll also see it here. So we can just move our screen here. And then once we have created 6 marines, we'll be selecting them and we are going to attack. Because we've written higher than 5, that is why we are selecting 6 marines, or waiting for us to have 6 marines. If we set higher than and equal to 5, then once we reach the number of 5 marines, we will just be selecting and going to attack. And what you will see here is that we are probably going to lose, because it's not that good of a strategy to build one barracks and just wait for 6 marines to pop out and go attack, because the enemy will probably have more units than us now. So before we reach part 5, I want you to go into the code that you have written and optimize it so that you, instead of 1 barrack, build 2 barracks and then train double marines so that you are outputting 2 marines every time. And as we saw, our marines didn't attack anything, and that is because we misplaced this if statement here, attack, we misplaced it under this if length of marines, where we are selecting the marines. And the reason why that caused our marines to stop attack or don't move at all is because of the static way we have implemented this. So once we read this if statement, it will continue to return this select right here and never get further down the line. So we just put our tag up here because that will first get executed based on the parameters here once we have selected the marines. So if we try to execute this again, So now we are back, and it should continue in the same path as before, with a supply depot, a barrack, 6 marines, and then it should attack. So now we just need 2 marines more. And now we have the marines, and they are moving, so they will be attacking right here. So let's see what the enemy has. It has some... Oh, so we are playing a Zerg right here. That means that we actually might win this, because they don't have that many units. So we killed off their units and the drones. And back here we are recruiting new units for the next attack.
Everyone should have the opportunity of influencing the world of tomorrow by learning high-impact tech skills. Take back control of your time and stay efficient by planning your daily tasks and learning activities using the Academy Planner. Browse through your favorite personal resources and keep track of your learning progress. Our belief is that people learn differently, and we do therefore support resources from around the web to ensure the best possible experience. The Social Hub enables you to connect with like-minded users. You can either dive into already established topics or be a first mover and create new topics that can inspire other learners.